Lesson 14.11 is solving systems of equations with matrices, but now I'm going to teach you how to do it on the calculator because you already see number 1 has 3 variables in here. That would be a total pain in the butt to manipulate this until you get your reduced row echelon form. But let's think about reduced row echelon form. You're going to see this abbreviation on the calculator. Okay, and then your reduced row echelon form is, we have to put this as an augmented matrix first. It's going to be 6, 1, -8, -3, -5, 4, 8, and -8, 9, 9, -2, and 3. Now on your calculator, you won't have this line in here. It's just going to be a 3 row by 4 column matrix, a 3 by 4. What we want it to turn into is going to have where it's 1x, no y, no z, equaling a number. We're going to have 0x, 1y, no z, getting a number, and then no x, no y, but a z, getting a number. So this will be our solution. Okay, so what you want to do is go to your matrix, edit, put in that it's a 3 by 4, and I've already got mine in there. Putting in this, and then go second quit, or back to second matrix. Now we're wanting to find this RREF. So go over to math. It's way down here. And be very careful because there's one that looks just like it. There's REF, which is reduced, or no, that's row echelon form. It's close, but it doesn't quite give us what we want. I'll actually show you what it gives you. Okay, so see how this doesn't give you zeros here and it gives you more ones? That's bad. So you don't want that. We want to go RREF. That's option B. Then you want to go back to your matrix and pick matrix A. Hit enter. And there it is. It's beautiful. So that's 1x, or x is 4. That's y is -3. And z is 3. Oh, that's so nice. I don't know if you remember from Algebra 2, we used to have to take 2 of these equations and get y, or one variable, I'll say, x, y, or z to cancel, take 2 more equations, get that same variable to cancel, put them together with elimination. It was a whole process. So this is a really good strategy for ACT that can speed you up if you ever have them. All right, let's try this with some word problems. These are actually taken from Algebra 1, but I want to show you how you can use matrices for these. It says a paper company needs to ship paper to a large printing business. The paper will be shipped in either small boxes or large boxes. The volume of each small box is 6, and the volume of each large box is 18. A total of 27 boxes of paper were shipped with a combined volume of 342 cubic feet. Determine the number of small boxes shipped and the number of large boxes shipped. So I'm going to let my small boxes be X, and it's the number of them, and the number of large boxes be my Y. You could use S and L, just know what you're putting on your calculator is going to be like your X and Y. So it tells me that the volume of each small box is 6. So it's 6 cubic feet times each small box, plus large box is 18 cubic feet per large. And we don't want the 27 there. We want to know what is the total volume, which is 342. So there's one equation. Then it also tells me that there's 27 boxes total. So the number of small plus the number of large should equal 27 boxes. So that could be 20 and 7, or 7 and 20, or 12 and 15, all those combinations. But this now allows me to create my augmented matrix that I can put into my calculator. So it'd be 6, 18, 342, 1, 1, 27. Okay, so go second matrix. We're going to edit. We're going to call this a 2 by 3. Second quit. Second matrix, go to math. Remember, go all the way down to B, RREF. And then we're going to put matrix A in there. And that tells me that X is 12, and X was my small. And that Y is 15. So 12 and 15, which actually does add to 27 boxes total. Pretty cool. All right, and then number 3, at the beginning of the year, Skylar has $30 in savings and then saved an additional $16 each week thereafter. Faith started the year with $100 and saved $6 every week. S is representing the amount of money for Skylar for T weeks after the beginning of the year, and F represents the amount of money Faith has saved T weeks after the beginning of the year. Write an equation for each situation in terms of T and determine the amount of money Skylar and Faith have saved in the week that they have the same amount of money. Okay, so Skylar started with $30. That's our constant, or like our y-intercept. Plus, she's saving $16 every week, and they're wanting weeks to be T. So be careful on delta math. You got to put in T instead of X. Faith started with $100. She's only saving $6 every week. Then we've got to figure out the amount of money. So think about this as an ordered pair. I want to do X and Y. This is the T, or the weeks. This is the money saved. So we're actually going to want just the Y value. But what I want to do is go ahead and think about this as being Y equals 30 plus 16. I'm going to go back to X here for my work. And Y equals 100 plus 6X. I'm going to move the 16X over. So now it's negative 16X plus Y equals 30. And negative 6X plus Y equals 100. And so now that allows me to make my matrix. And then put it on my calculator and do reduced row echelon form. And you should get that X is 7 and Y is 142. So this means that after 7 weeks, they both had the same amount of money, and it was $142. So the 142 is the answer that we want. If we would have said, if they would have asked at what, or after how many weeks did they have the same, you would just say 7.